Welcome to this XDK2MAM video tutorial. Today, I will guide you step by step to set up the UDP package that's going to allow us to send the XDK110 census data through Wi-Fi to a Node.js server that will listen, get this data and publish it to the Tangle using masked authenticated messaging or MAM. But first, what is UDP? Well, it stands for User Datagram Protocol, and it's an alternative to TCP, used primarily for establishing low latency and loss-tolerating connections between applications on the internet. So first, let's see what we need. XDK Workbench, an Eclipse-based IDE. If you don't have it installed, you can go to xdk.io. In the downloads section, find the version that suits your OS. This software is essential to import the code and flash it to the XDK110. You will also need to have Node.js installed. You can get it by entering nodejs.org and downloading the version that suits your system. If you want to know whether you have it already installed, you can type the command line node -v. If it returns a version number, then Node.js is already installed. Lastly, the git command line is not mandatory, but it's a handy tool, so you might want to install that as well. Once we have all the tools we need, let's begin by heading to the XDK2MAM website and into the section The Code. Here you can find different solutions that will allow you to send the census data to be published to the Tangle. Today, we'll be using the UDP microSD card. We'll be relying on the Wi-Fi connection to send the data, but in this case, a microSD card is going to be used to store the config file that includes the Wi-Fi connection data such as the name, the password, and the IP the data will be sent to. This version is much more portable, since you can take your XDK110 from one network to another very easily. All settings will be saved onto the microSD card in the XDK110. And then you can easily modify the Wi-Fi or IP data without having to recompile and flash the code every single time. You can just change those values in the config file within the SD card, plug it into the XDK110, and you're ready to go. So now let's get to GitHub. Here we have a folder that contains the C code that we'll be flashing later to the XDK110. There's another folder that contains the Node.js code. And this is what we'll be using to start a server that's going to listen to the census data from the XDK110, and it's going to be in charge of publishing the data to the Tangle. And finally, we have the config file, which is where we will place all our network information. Now, let's go to the repository and clone this URL. As you can see, here I have created a folder called Tutorial in the C drive. So we'll do a git clone and clone the whole repo into this folder. Now we have a new folder called XDK2MAM, and inside it you will find the code for all the available methods. Since we want to keep this folder clean, we'll delete everything except for the UDP SD card folder, which is the one we'll be using. In this folder you'll find the contents detailed on the GitHub repo. Next, we can edit our config file. This file should be copied onto a microSD card. We are then going to edit its data to match our network. In the first value, device name, you may enter whatever you want. If you're going to be working with many devices, it's a good idea to label them separately. Then you must enter your Wi-Fi SSID, your password, and next, the destination server. I want to use this computer and run Node.js on a server that's going to keep listening. So I need to know what my IP is. So I'll type ipconfig at the command line, and this is it. Once we place this config file into the microSD slot that goes into the XDK110, and we compile and flash the code, the XDK110 is going to know that it needs to connect to this Wi-Fi network and will begin sending the data from the sensor to this specific IP. We won't change the port number, and then you'll find the interval in which packages of data are going to be sent. This is in milliseconds. Below you can see the available sensors. Environmental, which includes temperature, pressure, humidity, then accelerometer, etc. And everything's on now, but you can set some of these to off if you don't want to share this data. So we'll save this file and remove the SD card from the computer. Then we'll insert it context up into the XDK110's microSD slot. Once the config file is ready, we'll head back to XDK Workbench, where we'll be importing the C code we just cloned from the repo. In the File menu, go to Import, and inside the General folder, select Projects from Folder or Archive. Then you must choose a directory, so we'll browse for the folder we created earlier, XDK2MAM, UDP SD card, and finally the XDK2MAM-C folder. Click OK, then Finish. Once the process is complete, right-click on XDK2MAM in the Project Explorer panel and select Clean Project. After the cleaning is complete, right-click once again and choose Build Project. This is going to compile the project, and depending on your CPU, this might take several minutes. The compilation process ended correctly. Don't worry if you get some warnings, that's normal, as long as it states that the compilation was correct. Now we have to plug the XDK110 to a USB port in our computer and then turn the switch to on. As you can see, the device is promptly recognized. We now need to click the Flash button. The microSD card with a config file in it is already inside the XDK. So when we click the Flash button, you might want to keep an eye on the console, where the details of the flashing process will appear. Once the project is finished, it's going to attempt to start sending the data. However, since we didn't set up the Node.js server that's going to listen for those packages of information, the process won't be completed yet. Then what we need to do is go back to the command line and address the Node.js folder. In order to install all the dependencies needed, we'll enter npm -i and wait for a moment as it installs. Now that it's done, if we take a look inside the Node.js folder, we'll find the file server.js. This file has to be edited to make two basic changes. First, we must provide an IOTA full node with proof of work enabled. And we should also change this random seed for our own seed, which is an identifier for the channel we will open with mum. First, we'll be replacing the full node. If you don't know which node to use, you can go to iota.dance and choose one of the nodes available there. Make sure proof of work is checkmarked. And then enter the node data in this section of the script. The next thing to be changed is the seed. This is an identifier for your channel, and your data will be on the same channel as long as you use the same seed. Here you can see the part of the code that's in charge of generating a random seed. We could use it as it is. However, if we want to make sure all our datasets are published to a single customized channel known only to us, then we have to delete this part of the script and add a seed of our own here. Remember, the seed must be exactly 81 characters long and be comprised of uppercase letters A to C or the number 9. We are going to save this file, and the final step is to get the Node.js server running. In the command line, we'll enter node space server.js, and that's going to start the Node.js server using the port we specified in the config file. Remember, we set a 30-second interval, and the proof of work might take a couple of additional seconds. So, after a short while, we got our first dataset with all the census data and the channel ID. You can check that the data is synchronized by copying that ID, then entering thetangle.org, then going into Services and MAM Decoder. Paste the ID here and hit Decode. The data sent from our census is displayed here, and it can be seen in trytes, JSON or TXT. So, we just sent the XDK110 census data to the Tangle using the XDK2MAM UDP microSD card package. The datasets are now decentralized and unchangeable. And this is it for today. Thank you for viewing this XDK2MAM video tutorial. For more information and resources, go to xdk2mam.io.